Hello, my name is Alex. Today I'll be discussing the atom, the periodic table, and the mole. So to begin, the atom. What is an atom? An atom can be defined in many different ways, one being a form of matter that can be broken down using any chemical means. Not to go off on a tangent, but any chemical means is included in the definition because the atom can be further broken down by other means. And that breaking down of an atom has resulted in the creation of the nuke, in which atoms release tons of energy to basically make a bomb. One example being the hydrogen bomb. Okay, the term matter in the definition can be defined as a physical substance, that which occupies space and contains mass. So basically anything you can feel or touch that holds mass. Another definition for an atom is the basic unit of a chemical element. The term element in that definition means a species or type of atom. Fun fact, while thought to be the smallest unit of matter, it is actually the second smallest, with quarks being the first. So here's an actual image of an atom. The exact atom is strontium, and it is the little white ball you see in the middle. Okay, so here's an image of an atom most of us are used to. And in the photo we see 4 labeled parts, which are the subatomic particles that make up an atom. The 4 parts are the nucleus, protons, neutrons, and electrons. To begin, we see that in the middle it is labeled nucleus. Within the nucleus there are 2 subatomic particles, one being protons, which are a subatomic particle within the nucleus with a positive electric charge. The other is the neutron, which is a subatomic particle of about the same mass as a proton, but without an electrical charge. The protons and neutrons within the nucleus account for most of the atomic mass of an atom, because electrons virtually have no weight. Outside the nucleus, we see orbitals that are holding small blue balls. Those small blue balls are electrons, which are subatomic particles with a negative charge. That negative charge is usually equal to the positive electrical charge from the protons within the nucleus. Now that we have identified and talked about what an atom and an element is, we will move on to the periodic table, which holds all atoms and all elements. Here we see there are numbers running across the top and on the side. On the side, these numbers represent the periodic table's periods. So period 1, period 2, period 3, all the way until 7. On the top, the numbers represent the groups. So groups 1, groups 2, all the way through 18. This is a means to see and locate whatever element you're trying to talk about. I will now identify different parts of the periodic table. Group 1 is considered to be alkali metals. Well, all elements except for hydrogen, because hydrogen is considered to have different behavior. For group number 2, these are considered alkaline earth metals. For groups 3 through 12, these are considered to be transition metals. All the elements with the blue dots are post-transition metals. The elements outlined in black are metalloids. The elements with the green dots are other nonmetals. And last but not least, group number 18 are noble gases. The atomic number within the periodic table is also incredibly important because it represents the number of protons for each atom or element within the periodic table. So the number of protons for oxygen would be 8, the number of protons for tin would be 50, and so on. The atomic weight is also very important for the periodic table because it represents 1 mole of each element or atom in grams. So for hydrogen, it's 1.00794. That is 1.00794 grams of hydrogen, which is 1 mole of hydrogen. Before we move on to the last topic, here's a meme that involves chemistry and uses elements from the periodic table to spell out modern problems require modern solutions at the bottom. Next, we will be talking about the mole. So the last topic that will be discussed is the mole. In this image, an actual mole has a text bubble next to it saying Avogadro's number. Avogadro's number is the number of atoms or molecules in 1 mole of a substance that is equal to 6.023 times 10 to the 23rd power. So that number there is used to find the mole of any element within the periodic table. Thank you to anyone who made it this far into the video. I hope the video was informal and not hard to follow along with. Shout out to period number 3, Miss Quintero. And that's all. Bye.